Hello everybody, it's the third video of our 3 integration videos, video number 3. And here is our exam question. The line with equation y equals 10 cuts the curve with equation y equals x squared plus 2x plus 2 at the points A and B. And we've been asked to find the area of this shaded region R. Now, you might think that we could just use integration straight away to find the area under the curve, but remember, integration only finds the area between the curve and the x-axis, so it will not find this area here, okay? That would be a mistake. It would find the area underneath the curve and the x-axis, so kind of like all this stuff here. So what I've done is I've drawn some straight lines down from A and B, these 2 points, and indeed, we're going to find at some point this area, okay? Now, overall, we want to find this area R, don't we? Area R, this thing in green, equals, now it's going to be that large square, like so. Take away this kind of curved shape that I've shaded in blue. The green shaded and stuff is going to be the red stuff, take away the blue stuff, and that's exactly how we're going to proceed. So this stuff we're going to call area 1, and the blue stuff we're going to call area 2. So let's try and find area 1. Now, in order to do that, we need to find out what these 2 coordinates A and B are. Now, we know they lie on the line y equals 10, and we want to find the place where the curve, this curve here, intercepts the straight line. So we can just set them equal to each other. So we have 10 equals x squared plus 2x plus 2, and that's something to solve. Rearranging, I get this. Factorising, I get this. And so that we have x equals minus 4 or 2. And I can now fill this in on my diagram. This point, therefore, must be minus 4. This point here is positive 2. So what is the area of this big rectangle? Well, I know that this width is 6, and I know all along that this height is 10 because it's the line of y equals 10. So area 1 equals, well, it's going to be just 6 times 10, which is 60. Okay, so I found area 1. Area 2 is the area trapped between the curve and the x-axis. This is exactly where we can use integration. So this is going to be the integration between 2 and minus 4 of the function. And this equals, remember, square brackets, and I've got x cubed over 3 plus 2x squared over 2 plus 2x, close the square brackets and put in my 2 limits, 2 and minus 4. And now I can get ready to substitute these limits in. So remember, I have to have my 2 brackets, there they are, and I start to substitute them in. Quickly notice that this second term, the 2's cancel. So there's my first bracket, 2 cubed over 3 plus 2 squared plus 2 times 2. My second bracket, I have minus 4 cubed over 3 plus minus 4 squared plus 2 times minus 4. And now we can simplify these things, and I get all of this stuff. And I'm actually just going to bung that into my calculator because I'm feeling a bit lazy. And this gives me 24, and that is the area of area 2, this kind of shape here. And so finally, I'm ready to do my final calculation. R equals, well, it was area 1 minus area 2. And so this equals 60 minus 24, which equals 36, and I'm done. I'm going to reward myself by highlighting my answer. So the second question says, figure 2 shows a sketch of the curve with equation y equals root of x. Okay, so we've got this curve, and we've also been given a shaded region. Now, the really important thing to notice is it's told us that the area of R is 10. So I'm going to kind of highlight that on my diagram, and I'm going to also just say that this equals 10, just so I've got a visual sight of what's going on. Now, the reason I've chosen for us to go through this question is it's a slightly alternative question. It's using an unknown, which we've got A, so one of our limits is an unknown, and we're going to have to use our knowledge of integration in order to think a little bit more outside of the box in order to answer some of these questions. Part A says, find in its simplest form the value of the integral of root 8 of x. Okay, now, we know that R, which equals 10, equals the integral. Remember, the integral gives us the area between 2 limits, so between a and 1 of root of x dx. So we know that that equals that. Great. Now let's think a little bit about the thing that we've actually been asked for, the integral of root 8 of x. The integral of root 8 of x dx, well, I can just rewrite this as root 8 times root of x dx. And you'll notice that root 8, well, even though that's a surd, it's just a constant. So I can take that outside of the integral, okay? It's just a scalar. This is root 8 times the integral of root x dx between a and 0. And now I hope that you'll notice that this thing here is exactly the same as what we started with, our R region. And we know that that thing in the blue brackets is just 10. And so we've got a final answer. This is 10 root 8, which rearranged is 20 root 2. And I've done my first part. Part 2. Now, this is a slightly different integral. It is different limits. We're going from a to 0. We need to have a little look at the diagram for this one. So let's just zoom back into the diagram. Now, this new integral that we're trying to find is represented as the area between 0 and a. Okay, so it includes this tiny little bit of area at the start. Okay, so I'm just going to draw that in. And to work out the whole total area, we're going to need to add in this first part to this second part, okay? So I know what the second part is. I know that this second part is r, and I know that equals 10. But I haven't worked out what this first part is, so I'm going to work that out. It's going to be the area under the curve between 1 and 0. So let's just write that in mathematical language. We know that this is the integral between a and 1 of root of x dx plus the integral between 1 and 0 of root x dx. Now we've already said that this first bit, this is r, that region that we know is 10. And this second bit, we don't know what that is, so we're going to work that out. So this is 10 plus, now I need to integrate this. So this becomes, in square brackets, well, root x is just x to the power of a half, so this becomes x to the power of 3 over 2. I've divided it by that new power. Okay, and this is between 0 and 1. Let me just take a line to simplify this. So this is 10 plus 2/3 x to the power of 3 over 2 between 1 and 0, which equals 10. And I can go straight to my brackets now. This is 2/3 of 1, take away 2/3 of 0. This equals 10 plus 2/3, which is just 10 and 2/3. So that is my answer to part B. Let me just recap what we did. We were asked to find the integral between a and 0, so the whole of this area, okay? And we knew already this subsection, so we were simply working out the other tiny little bit on the end, this kind of little wedge, and we were adding them together, which is exactly what we did. We did 10, which was that original R region, and we added on the extra little integral, which we worked out to be 2/3. Okay, part B says show that a equals 2 to the power of k, where k is something we've got to find. Now, don't worry too much about this yet. Remember, just try and work out what it's asking you to do, which is essentially find a. Okay, so let's find a. Well, we know that r, which equals 10, remember it's that shaded region, was the integral between a and 1 of root x dx. And we've already said that that is 2 over 3 x to the power of 3 over 2 when we integrated it in the second part of this question. But this time the limits are between a and 1. Make sure that you're happy with the fact that the limits are the limits of this region R this time. So I can write on my next line. So we know that 10, this whole thing, equals whatever this square brackets turns into. And so we can move this into substituting our two limits in as we normally would do in integrals. So remember, we're just doing everything that we normally do. This region R is just an area which we know is 10. And we're just doing what we normally do, except this time we've got an unknown as one of our limits. But that doesn't matter, we do all the same stuff. So we firstly substitute our a into this function and take it away from the same function but substituting 1 in. So let's do that. So here are my two brackets, and I'm going to substitute a in firstly. So this is 2/3 of a to the power of 3 over 2, take away 2/3 of 1 to the power of 3 over 2. All I've done is substitute those two limits into my function and taken one away from the other. Hopefully that's clearly demonstrated by the highlights. And now I can simplify this even more. So I have 10 equals 2/3 of a to the power of 3 over 2 minus simply 2/3. This implies that 10 plus 2/3 equals 2/3 a to the power of 3 over 2. And now we just need to hold our nerve a little bit here. Keep going. So this is 32 over 3 equals 2/3 a to the power of 3 over 2. Multiply both sides by 3, so I get 32 equals 2a 3 over 2. And divide by 2, so I get 16 equals a to the power of 3 over 2. We're getting there, we're getting there. Now, do you remember that the question asked for a in the form of 2 to the power of k, with k some number. So it's going to help me a lot to change 16 into 2 to the power of 4. And I'm well on my way. I'm going to square both sides. So 2 to the power of 8 equals a to the power of 3. And finally, I'm going to cube roots at both sides. So 2 to the power of 8 over 3 equals a. Turn it round, so a equals 2 to the power of 8 over 3. And this is in the correct form that we wanted, isn't it? So I can highlight it. I'm very pleased. And I can probably finally say that k equals 8 over 3. And I'm done. Thanks very much. See you soon.